Now I want to take your attention into this also. Now remember, in the cybersecurity space, the key thing, the key use case which OSINT is penetration test, right? And I want to highlight that for you also, one of the key things that you failed in this task is basically you directly went into the attack and you failed in this. So, like I said, I said there is just one small thing that you missed, right? So the small thing that you missed is intelligence gathering. And now this is a very good use case. Overlooking project is a very good use case. Why? You need to do a proper intelligence gathering, the data collection, and then use that to intelligently do the attack. What you did was directly went in, right? And that was not the correct part. Rather intentional also. Do shop we already did, right? I think we used that in the course itself. Why do not have the exact same thing there for you to break, right? So remember, very good example for why OSINT is there also. You have to use the information. I think in this case, so we've. I think one key point is this discussion of what constitutes as a attack and what constitutes as a open source intelligence information gathering. Now here, of course, I think a lot of all the group is code scanning, right? Otherwise you don't know where to enter. No? So we will, of course. I think in the lecture also we discussed this. Now, generally, if I ask the question, where does code scanning fall into, right? Okay, let's answer this again. Code scanning, OSINT, or pen testing, attack or just open source intelligence. People who say it's OSINT, people who say it's pen testing, people who say other answer?
Depends.
Okay, at least one person gave the correct answer. Okay, why is it
only gather the information from whereas the open port and
only gathering information? Why is it right? Why is it attack? You said pen testing.
Basically, the reality is it depends on the context. So based on our intention, it changes.
That's the correct answer. Now, for example, if you are going to do a hack, if you are going to break into a product, and then for that particular purpose you are doing a port scan, that is not open source information gathering. That is purely first page of attack. But in certain cases, say this is example, your own organization, you're the internal IT guy, person, and you want to see, okay, how secure is our setup. When you do a port scan, that is not attack. That is just seeing for a public, like somebody who's accessing from public, what do they see? What is open source information of our organization? And I want to verify them as an internal person. That is OSINT, right? So purely like the proper answer is grey. It's not black and white. You can't pitch it to what part of the other. It depends is the correct answer, and you have to say why it is that answer, right? So now there are other purely. Now what is open passive information gathering, semi-passive and active? What the key point? Passive is
without target knowledge.
exactly. So you have the target, and you're going to you're going to find information without directly interacting with the target. So this is Wayback Machine, right?
Yeah.
So this is, if it's www.google.lk, If you put it here, it will give you information about Google.lp without interacting with it. Active is that side. So directly interacting with the target. And what is semi-passive? You are going to interact with the target, but it appears to be normal traffic. So if you are doing some data gathering, and the use case here is your client has specifically stated that the target should not be aware of open source intelligence work being done on them. So they should not be aware of that, right? So it's then semi-passive, right? Sorry, the approach that you have to take is semi-passive. So you can of course interact with the target, like if it's a server, you can interact with the server, but it has to appear like normal traffic. You can't do brute force, things like that, right? So now the question, so these are 4 types. So the key thing that I want to emphasize in the foundational lecture is that lot of the cases in OSC, it is extremely context specific, right? You cannot like pinpoint certain stuff and say something as a rule. Port scanning is pen testing. Can't say that as a rule, right? And this is why lot of your questions in the paper will also be case study driven. I'll give you the case, you have to study the case, and you have to see the background, and then apply these things and then give out the reason. For a lot of the questions, there will be both sides of the answer might be correct. There might be a better answer, but there might be another answer that is not that exact answer, but if you reason out things, you can still get some marks, right? So that's what I want to say in week 1. So week 2, now I said even with OSC, basically we want to have a systematic method of doing OSC, right? So the reason is that when you're actually getting open source information of a target, if you don't have a systematic way of doing that, you will easily get overwhelmed. So you see this situation, very specific target, and I didn't give you background information, nothing, but still you were going in the wrong direction, right? So think of this in an actual project. In actual project, you will have a whole lot of other distractions, data sources, right? And this is why you need to clearly have a systematic way of doing this, right? So what did we discuss? So this data collection, OSC protocol, right? So this is the mapped into the systematic literature review protocol. You start with the intelligence objective. So even in your case, if you try to clearly say, okay, what am I trying to do here? The objective is there's somewhere in this server a list of agents, and then there are certain information that I need to take out of the server. Overall objective, intelligence objective. Then what did we do? We then created intelligence questions. So that is the broad objective, and then the next one are the specific questions, intelligence questions that you are going to ask. Okay? Second question. To find the agent list from the sources, which port or which service am I going to further explore? No questions. Questions වල answers ගන්න එක නේ දැන් අපි project එක කරන්නේ. Right? So if you do a port scan, you possibly find about 5 services or open ports that you can actually use. Right? Then you look at the objective. First question is, okay, from these sources, which particular service am I going to further explore to achieve the intelligence objective? So see, do you see how, now this is of course very short example, like a very short case, but in actual projects having this helps a lot. Number 1 with your project, number 2 with the reporting. End of the day you're going to prepare a report, right? It's a pen test, you're going to prepare a pen testing report. So you can structure this based on this style: objective, questions, data collection protocol. You have inclusion criteria, exclusion criteria, right? And validation and quality assessment. So this is the quality assessment criteria. Basically, when you actually extract the data, you have a specific set of attributes that define, okay, this is of acceptable quality to be passed to the analysis stage, right? So that's the data quality assessment criteria, quality checks, and then reporting and synthesis. So for the analysis, you can. So what we do is in general projects, we of course specify all of these things. Now, for example, analysis. What kind of analysis are we going to do? Right? The graph analysis, or based on the data that you selected, you can prescribe what particular analysis that you are going to do with the collected data. Right? Okay, so the planning stage. Now, in the planning stage, basically, we had, so these are some parts I mentioned. This source for the planning, these are flow diagrams, but I think okay, so the planning stage basically now, if you are doing within project, one of the key things is tools, right? It's very unlikely that you are going to do a within project without using any tool. You can, but in most you're working in the digital space, right? So most probably you'll be using a tool, right? So in the planning stage, one of the key things that you can do is you can first determine what type of data that you're going to collect. What were the three types that we discussed? Structured, unstructured, and semi-structured, right? So my experience is you rarely get this type structured data in OSN projects. You can in certain cases, but rarely. Mostly you get these two types, right, in terms of data, and then finally selecting the correct tool that fits into your objectives and the type of data that you are going to collect. Right? Not all data support all data types. I mean, lectures are only one key development then I something. Okay, then බලන්න මේ tool list එක මේකෙන් මේ basically for our course we covered several key tools at Labsutka rating from domain and network analysis we did InMesh, right? From Internet of Things we did Shodan, all-in-one platforms we did Maldigo, and finally we did Burpsuit. So today I think Burpsuit is not here because it goes towards pen testing, but I will introduce it to you I think because it's kind of like a very highly used tool and it will be good if you have some knowledge on that. So okay, I think now this slide is a very important slide, right? Now this is a list of concepts that we discussed in the course, and this is not a comprehensive list, but the lecture also I said that these are some of the things that OSN practitioners regularly use, right? So in terms of data collection, we discussed now I think I discussed this before also, passive data collection, active data collection, and then one of the key things that I want you to focus is this next area. analysis and entity relationship. Okay, so with OSINT, there are cases where you are going to get data about the entity using different tools, or same tool with the entity you can get different angles of the entity, or you can also get data about data, which is metadata, right? And now you are faced with a whole lot of data, right? And I've said this before also. In OSINT, the easier part is data extraction, right? Even the source that I gave you, the server, you can of course get a whole lot of data there. The important part is finding the relevant data, right? And this is the link analysis and link and entity analysis is one key technique that we covered. Remember the lab also that we did. You also went to the board and did the link analysis to find out relevant. So remember the particular use case. Both groups created a link graph, and I asked you, okay, to bring down this crime network. If you have one chance to attack a node, what particular node that would you attack? If you read that end to end, if you read the text end to end, it seems like it's the leader of the network that needs to be attacked to bring the whole thing down. But when you did the link analysis graph, it was clear that there was a different entity that was actually working as a node that connecting different parts of the crime network, and that person had a more central focus in the crime network. And if you have one chance, it will be that particular node that would be ideal to be attacked. Now, how did you do that? Using link analysis, right? And data aggregation, correlation and context, again, for all of these things we did labs and covered theory. Yeah, multi-go is what we did for link analysis. Now, basically, we did both on paper, and we also use multi-go. I showed how multi-go actually supports link analysis. Okay. Another very important point: false positives and data noise. Now, again, I think your project is an example. You were actually focusing on the noise, and you were not going towards the signal, but you were engaged with the noise, right? So, in terms of OSINT projects, identifying what is the noise, what is the signal is extremely important, right? Right, I think we didn't do a lot of social media intelligence now for the previous, not this year, the year before. I had a more stronger focus on social media intelligence. But now, for example, during that course, I had a different lab session for image analysis also. So this is basically because data extraction using Twitter, Instagram and all that was much easier those days. And this is why I did those, we did Twitter and we did Instagram, and then I showed you, and then the Google Maps, the map geographical intelligence. So there we wanted to see how image processing related techniques can be used for the analysis of open source data, right? For example, we were looking at certain targets, like certain objects, out of a whole, like a big data set of images, like 1,000 images. There's a particular pattern that we are looking for, and we did some labs on that. So for the last iteration and this iteration, I have a little bit of a limited focus on social media intelligence, purely because the data extraction is much harder. Even with Twitter, you can't, without the API, you can't get the extracted data. Instagram, same case. The data extraction is extremely hard now. So that is why I didn't do that, but it's a it's a very important area. And I forgot one key tool, recon.ng. Okay, very important tool. Why? Because it's not one tool, right? It's a modularized framework where you allows the user to bring in different modules. Now, even in this case, you could have used nmap in recon.ng and then taken the nmap output, automatically feed it to another tool, and then use analysis like a full pipeline. Right? So CI/CD pipelines are very developed. You have the code from one tool directly. You can transfer code from one platform, one tool to another tool. Same concept. You can develop tool pipeline, right? So recon.ng. These are the plugins, not the specific tools that you can take. Okay, so we discussed Shodan also. It's very, in terms of in the local context, this is a very, I would say, very important tool, because we generally don't pay a lot of attention for this endpoint security, right? For security, when we say security, our mind goes to server, security of the software and all that. But with these small IoT devices, we rarely think, this is what. This CCTV camera example, CCTV camera. We never think of the security of that as an endpoint, like a device that could be attacked, right? That's generally not something that we would see. Now here also some of the breach points are what? Cameras, these CCTV cameras, and so basically endpoint security as it relates to IoT, endpoint, Internet of Things security. Shodan, the important tool. Okay, I think this is a favorite question of mine. Now, data. So we are planning. We discussed planning, and now we add analysis, right? Analysis of data. Last time also, I think we had a question, right? So the question was, okay, for this particular data set, how would you do the analysis of the data? What are the key steps? And in which order? Then I can ask the question, if we change the order, how would it affect the result? Or how would it influence the outcome of those impressions? Right, that is something. Now, I think I would not ask the same question, but most definitely the data analysis part, I would answer the question, because I think that is key for OSC, right? So you have more, like I said, collecting data is using running the tool, evening work. I didn't do a tutorial kind of thing, right? I think that's not that hard. But after collecting the data, how you are going from a whole large set of data to the exact intelligence objectives, that is the hard part. And everything that comes in the middle, like the data analysis steps, those are important and sometimes hard to do also. Okay, so in terms of analysis, basically we covered 3 particular techniques, right? We first did the simple statistics. I think I have let me quickly the slides and so this is what I mentioned: data cleaning and preprocessing, removing text elements. We use Python, things like lowercasing, organization, stop word removal, stemming, lemmatization. So, sample code, handling outliers and all that. Discussed. And then this is the data analysis techniques like, yeah, sorry. So then data transformation. Now remember, data cleaning is one thing, data transformation is another thing, right? So I hope the boundary between these two is also clear for you. So data transformation is you have the raw data, and for it to be useful for the analysis tool or analysis technique, it has to be transformed into a different format, right? So that's data transformation. So basically now if you do things like this, scaling, encoding, feature engineering, data splitting, all of these are data transformation steps. So we discussed some of these things: scaling, normalization, standardization, scaling methods, encoding, right? So low, medium, high. So what is this? You have a whole lot of data, and you want to simplify the analysis where you assign a category for each data point, right? So, for example, assign an integer. So you categorize and then you assign an integer for the categories. So there are different techniques that we discussed about encoding and then scaling. So this is basically you have things like different data points, but the scale of these data points are extremely different. Example, you are going to analyze Facebook posts. Two types of data points that you can identify is number of likes and number of comments, right? Can you use the same scale to analyze these two data points, likes and comments? Very difficult, right? So if you put to a chart, these two things, and then one will be like this. If it's the same scale, if you use the same scale, right? And one will be like this. Why? One actually is in a different scale because number of comments are very less and number of likes are higher than that. So you have to do some sort of scaling in the data, right? Feature engineering, data splitting. Okay, so for data analysis, basically we discuss several key things, two key categories. First one is statistical. So my recommendation is still, if you are using if you have a data set, don't dive into machine learning. See whether simple statistics can actually get you the output. And in certain cases, machine learning will actually screw up the model. It will actually not give you the findings that you want, because I mean, for example, I've seen this in a lot of projects who don't understand the fundamentals. Machine learning models are applied where the data set is very limited. The model is therefore, I mean, with machine learning, it's always garbage in, garbage out. If you put garbage into the model, most definitely the outcome that you get is also garbage, right? So if it's a small data set, right? If it's a niche data set and that kind of thing, maybe you try to start with statistical methods and then you can move to machine learning. So when I say statistics, the stuff that you know, mean, median, average, the basic statistical techniques, not fancy, but sometimes that is the way to go, right? So with data analysis, then we move into machine learning, right? So in terms of machine learning, what did we cover? We covered 3 techniques. What are the 3 machine learning techniques? 3 machine learning categories. Can you answer? 3 machine learning categories? Supervised, unsupervised, reinforcers. Okay. So for each, what did we cover for supervised learning? What did we cover in the course? Course we used a particular technique. Supervised learning. Yeah, supervised learning. We are going to train a model, and it has to be a trained model using labeled data. Correct. But what's the specific technique that we use? supervised learning model එක. මොකක් හරි model එකකට ඔයගොල්ලෝ data ටිකක් දුන්නා මෙයා classify කරලා පෙන්නනවද මොකක් හරි? model එකක් තිබ්බම model එකට ඔයා data දැම්මම එයා ඒක classify කරලා දුන්නා මේක මේක කියලා. ඒක කරන්නේ නැතව? Come on. model එකකට ඔයගොල්ලෝ data දුන්නාම ඒක එයා classify කරලා දුන්නා හරි මේක මේ category එකේ. ඒ මොකද මේ model එකේ ඒ categories වලට ඉස්සර train වෙලා තියෙනවා. ඒක readily available model එකක්. Huh? Sorry? Sentiment analysis, exactly. Sentiment analysis we use for model, right? Python වල අපි model එකක් අර ඇතුළට ගත්තේ import කරලා that is a already trained model where data is labeled data set එකක් ඉස්සෙල්ලා model එකට feed කරා. මේ මෙහෙම මේ words කියනවනම් මේක positive. මේ words කියනවනම් මේක negative. මේ words කියනවනම් මේක neutral. ඒකට model එක already trained, right? What you did was you clean the data set with Saragana, you cleaned it and then you feed it to you put it as input to the model and then the model produce, okay, this is positive, this is negative. You tweets you then aggregate it, right? Score plus minus 0, and then you aggregate it. So that is classic supervised learning, right? So the model, you are using trained model to do analysis, right? With supervised learning, the accuracy is a bit towards the higher side compared with unsupervised learning, but general state. Again, some rules again depends on the context again, based on the data set that can differ. Okay, unsupervised learning. What's happening in unsupervised learning?
Machine can learn itself. Can learn itself with the category classification.
The model learns by itself, right? It looks at the data set, it looks at the patterns, it looks at attributes that come together, and the model itself categorizes these based on the patterns that it has learned. For example, you have this set of tweets, and if you want to say, okay, for these tweets, I want to know what are the main topics that they are discussing online for a particular area, right? So then you use unsupervised learning, and then you can like if your one particular model is topic model. So topic modeling, the specific model that you use in LDA, I think. So using that model, using unsupervised learning, classified the data into certain topics, right? Can you do this in supervised learning? Can I do this in supervised learning? My intention is I want to categorize the data set. Can you do it in supervised learning?
No, we have a large set of data.
People who say can?
But can it take times? But can it take times? But not.
Take time. How?
Yeah,
Oh, yeah.
a lot.
Huh?
The manual one by one අපි check කර කර දෙන්න ඕනේ මේක මෙහෙමයි මේ වගේ account මේ විදිහට කියලා. එතකොට ඒක ලොකු data set එකකට but unsupervised learning වල that automate category.
Yes.
You can just remove the labels and
So remove labels it's not supervised, right? How would the model know that? How would the model know? If you are using supervised learning, you have to supervise the model first. You can do classification of a large data set using supervised learning, but you have to supervise the model first. You have to have a look at the data set manually, take a sample, and then you can say, okay, in this sample, the data that I see is these categories. Then you take that as a training set, you feed the model, you manually label, and then you feed the model, say, okay, if it is this is the category.
But sample can be included the other categories also.
Exactly. The error is then you can never say that the sample that you selected is a conclusive capture of the whole data set. There might be certain categories that is not there in sample. Number one. Number two, this is a time consuming, right? You have to then model training or machine learning or time consuming data. Model training. Therefore, unsupervised learning is very beneficial. Problem with unsupervised learning is not extremely accurate, right? Not extremely accurate, so we have to be careful. Next technique is reinforcement learning. We did it in the last lab. What does reinforcement learning do?
Try.
Hmm?
Try and
Hmm?
Trial and error.
Trial and error. Now, reinforcement learning is trial and error. Model learns itself using trial and error. एक experiment runs, याम कर reward function ने का optimize कराने को मतलब किया ने का या बात, right? That's it. Okay, link analysis I discussed, and so this is I think I have the resource also. So this is the level link analysis graph that we created, and I think I have this resource also this book, criminally utilized by the United Nations, and it has the steps also. So if you miss the lecture, no problem. The steps and how you can do this, how the techniques, and it's very simple, very like in very simple terms they have explained how the mechanism is done, right? So just have a look, and we actually did this with a case study, right, in the class. Okay, so then we then went into okay, these are your work. Into reporting, right? So make section importance එක ඔයගොල්ලෝ එච්චරම තේරුන්නේ, but if you are actually overseeing practitioner, health test කෙනෙක් වගේ, you would know that this is probably the most important section if you're doing as a business. Why? End of the day, what you're producing is a report, and the report has to be good, and the client has to be satisfied in what you're producing. Because no matter what you have done, if you produce a bad report, all what you have done becomes, the value drops, right? So I actually discussed my section basically. I extracted a few best practices. Reporting rules in report lecture make a first section. You can't do that, especially a domain like this. So the thing is, I can actually teach you some best practices, and you can of course use them for your own report. So the bluff statement, storytelling, tailoring, transparency, that's referencing, referencing the sources and avoiding bias, and visualizing. So these are some of the best practices. I selected a few, and then I presented to you. And then finally we discussed about a key thing with OSINT. Any OSINT tools has this, the discussion between OSINT and privacy, right? Because we are actually taking data out of, even if it's open source, you are actually taking data out of entities, right? When the entity is a person or organization, then the question of privacy comes into the picture, right? So we also discussed this in terms of different contexts, right? How different contexts and different countries actually talk about this in various different angles. So in certain countries, innovation gets a higher priority, productization takes a higher priority than the privacy aspect, and therefore data collection and open source data collection and feeding that data into products to make the product better places a high importance in those countries. Example, United States, and that is why they build a lot of products. Right? Europe, other side, right? Always privacy is extremely, it's actually one of the strictest places in terms of data privacy and personalized information. So a lot of these US companies are facing problems with the European countries. And this is the Cambridge Analytica case study. We hope we discussed that also. I think 11 to read the scripting, I have to delete the big data part. Alright. Okay, done. Any questions? Anything that you want to discuss more than this? Like any specific area that that you want to discuss? Exam paper, okay, no, ma'am? Same structure. So same structure that we had last week. The same structure of the last paper that I discussed last session. We have the same.
එම්බෙල් අසයින්මන්ට් එක අපි කරේ නෑනේ.
ඕන මෙතන ඕන.
පුකුන්නේ.
මොකද ඒක තුනක් තිබුණේ?
අර ඒක අර නෑ ඒක අර QS අර 6ක් දීලා 5ක් ගන්නවයි කියලා 5 නොකරපු අයට ඒක පාඩු.
යාරක තමයි. එහෙනම් ඒක පොඩ වාසිය නෙමෙයි කරපු ටිකක් තියෙනවා.
කරපු නැති අයට ඒක හොඳයි.
Then what I'll do is I'll open it tomorrow.
ඒක හැබැයි ඒක මේක කරන්න.
ඒකේ මොකද මට කරන්න කවර් කරන්න තිබ්බේ?
මේක ඒක එදා ඔන්ලයින් කරපු ඉඳ කට්ටිය මම කරගන්න බැරි වෙලා ඒ කියන්නේ
වෙලාව මදි වුණ එක නෙමෙයි නේද?
වෙලාව මදි වුණ සහ මේ තේරිලා තිබුණේ.
අර සර් ජැෆ්නා වල ඉඳන් කරලා ඉඳන්.
Okay, so what I'll do is on that particular submission I'll extend it for 1 week. Then
ඒතර 6න් 5 වැඩිම තියෙන පහනේ ගන්න.
very thin. You can all do all 6.
Yeah.
I'll take the highest part. Yes,
ඒකත් හයි.
only the unit.
ඒතර පහක් ගන්න.